Hello, my name is Andrei Glukharev. I am PhD of Murmansk Arctic University. The topic of my presentation is characterization of biomaterials obtained from mussel shells using acid and complexon treatment. Mollusks are important object of the global aquaculture industry. Their global production is more than 70 million tons. Meanwhile, it has been shown that during the processing of 1 kg of mollusks, from 370 to 700 grams of shell waste is formed. Therefore, shells of mussels and other mollusks are the main solid waste of fishing industry. Mussel shells are biomineralization product consisting of 95 to 99% calcium carbonate and 1 to 5% of organic matrix called the conchs. Mollusks shells are considered only as a source of mineral substances, while it is organic component which can be an important source of biologically active components and nutrients is not given due attention. The conchs of mussels consist mainly biopolymers, including insoluble proteins, polysaccharide chitin, as well as lipids and pigments. These substances are employed in the production of foodstuffs and a number of technical, medical, and cosmetic preparation. A typical widespread object of marine aquaculture is mussels Mytilus edulis. Mussels Mytilus edulis are the most abundant species of bivalve mollusks inhabiting the coast zone of Barents Sea. The purpose of the work was obtained organic matrix conchs from mussel shells in the processing of demineralization using two different demineralization agents, a soluble of hydrochloric acid and solution of EDTA, as well as to study the properties of conchs and to determine its potential use. The demineralization process was carried out as follows. Shells were placed in a glass beaker with a solution of a demineralizing agent in the ratio equal to 1:15 in the case of hydrochloric acid, or 1:10 in the case of EDTA. When hydrochloric acid was used, shells were kept in solution at room temperature for 6 days. When using EDTA solution at 59 degrees Celsius for 10 days. Every day the samples were removed from the solution, washed and dried. The demineralization process was when continued using fresh solution. Demineralization in EDTA solution does not cause notable destruction of the samples. The demineralized shells practically does not differ in appearance from initial one. The mussel shells, when treated with hydrochloric acid solution, undergoes significant changes in the upper layer of the shells. There is a significant destruction of the structure, as well as loss of hardness. It was found the sample is prone to delamination of the upper layer of the valve. Upon completion of decalcination, the conchs 1 obtained using hydrochloric acid become brittle, break, and crumble with little mechanical action. Conchs 2, isolating using EDTA, remain soft and bend easily. At the same time, sample of the conchs 1 have a twisted shape and moved out upper layer. Conchs 2 have a shape close to the shape of the original mussel valves. Demineralization of mussel valves with hydrochloric acid solution was completed within 6 days. The residual components of calcium carbonate ash was less than 0.7%. A solution of the chelation components EDTA is a less active demineralizing agent. The content of mineral substance in the valve practically did not change after 8 days of treatment with EDTA solution, remaining equal to about 3%. Since the color of the mussel shells is black-bluish, it is a suitable model for visualizing the continuous process of convex isolation. Removal of calcium carbonate demonstrating high contrast in the light, as shown in figure 4, optical microscopy data. Already after 2 days, part of the valve becomes orange-brown in color, which is an additional indicator of demineralization. The chemical composition of convex obtained by demineralization with hydrochloric acid solution and EDTA solution is presented in table 1. The convex obtained is a protein product when containing chitin. The demineralization of mussel shells in hydrochloric acid solution results in the rapid removal of calcium carbonate. Concurrently, the native structure of the organic matrix proteins is partially destroyed. Analysis of IA spectra indicates 1.5-fold decrease in the number of alpha helices compared to the organic matrix obtained by EDTA-based demineralization. Scanning electron microscopy and transmission electron microscopy studies have demonstrated that the treatment of mussel shells with hydrochloric acid solution result in partial destruction of the biopolymeric structure of the convex. In contrast, the treatment of mussel shells with EDTA solution have been shown to preserve the native structure of this organic matrix. The structure of the convex obtained with EDTA solution is similar to the organic matrix of the native mussel shell. The result obtained indicate that the use of EDTA is preferable for the production of convex. The development of food products with the addition of bioactive additives based on protein and chitin derivatives is of particular value because of functional properties. That's all. Thank you for attention.